Pretty soon you'll be shooting the moon.
Yeah. You see where
It's fine.
All right, I'm gonna look at some donuts. Thank you.
Well, how are you doing?
Hi, good afternoon to you. I'm doing fine. On a beautiful sunny day here in Madison.
I know, took my dog out for a walk this morning. It was like, this is nice. The leaves are just starting to turn now and not too cold, not too warm.
Looks like we have a great week of 60s coming up.
I know. Meeting my sister-in-law in Dubuque on Friday. We're gonna have lunch together there. She lives in central Iowa, so we meet like halfway in between.
All right.
It looks like a beautiful day.
Never know what you get.
No.
All right, this is what the piano is best for.
You need plates or napkins or anything?
They gave us napkins.
I know, nobody pays any attention.
Is it your birthday?
It's on Saturday.
Yes, well, I should go get a cake. Kringle will have to do. That's Kringle and Kay both did it.
You want plates or anything?
That's eight.
You don't like the company or you don't like the
I
cream?
don't like the company, they're very mean to a lot of people. How about old age? I thought they were the same company. Well, there's three Kringle makers in Tracy. Old age is on 16th Street.
What's the plate?
Their stuff comes in the white wax paper with the lighting chip on it. Your team Kringle is out over by Rubin. So the red. Oh,
The red tray?
Tray. And then there's a third one.
Racine has the largest Danish population with the exclusion of Iceland. Denmark. Yes, and as you know, historically Danes come in three sizes. Large, extra large, and way bigger than that. And when the Romans finished off with the Germans, they decided to go further north. And the Danes had female warriors. And I can imagine these big Danish women just waxing the floor with these Mediterranean type guys.
Especially in the winter.
Yes.
Good. Well, grab some before I have to eat more. Because once I'm done, man, I'm done. Oh.
Oh, oh. Actually, I wouldn't know
There?
This is good.
Yeah. Up there.
Yes. I know this is something I really wanted to go to.
Is this the veterinary acupuncture or is that tonight?
That's tonight.
And what's it?
Hi there, folks.
This is bacteriology and oxygen.
Oh, the oxygen, the space,
Yeah.
he's into space and. You want to sit here?
No, Max wants to sit there.
Who's in charge of this relationship?
Well.
That's something you need to ask yourself.
Cranial is your favorite, isn't it, buddy?
Oh, he doesn't eat nuts.
No.
He likes pork chops though.
He likes wine. Although he's not supposed to have.
Did you find somebody for the fifth time?
Not yet.
After all these years of zooming and stuff, do you feel like you understand how this all this works better?
Better? Yes. Halfway? No way. For example, that's my white shot there, and it's on the wrong axis. What I want to be able to do is to switch back and forth as the host and determine who's on the screen.
It's surprisingly hard to look for these gadgets.
I didn't have limits, so well, it's surprisingly hard for us to work these gadgets. I know it'll do something and then I can't find where to do it.
Oh.
You know,
Well, I don't know who's bribing us with the treats, but they're wonderful.
Yeah, I tell you.
Thank you.
Is it your birthday, Tom?
No, I'm just trying to accommodate people since our speaker won't be able to come in directly on time.
according to his email, it seemed to be a bribe.
Yes, it is a break.
Well, this is a speaker, it's gonna be late.
Yeah. Well, I went to the PLATO class Monday about your mind and your senses. And their audio system was down, so we couldn't use a slideshow. So we just spent, almost 2 hours chatting about what he's gonna show us once he gets his audio back. But it should be an interesting class.
Very pretty dog.
Thank you.
It was a great.
He's,
For sure.
He's a poodle doodle.
Is he? A poodle doodle, what is a poodle doodle? I don't guess it's
It's a real, that,
a purebred.
yeah, it's purebred.
That dog's a Labradoodle, that is the smartest dog I've ever met, so I can only imagine what a poodle might be. This dog trains,
It's not necessarily a good thing in a dog.
I know, this dog trains me every time I take care of it. Yeah.
They do have very easy train
Mhm.
because they come that way. Just instinctively,
Yeah,
and then they spend the next 14 years training you up.
Good morning, Mr. Newton.
exactly.
Hello.
And they're hypoallergenic, which I just, being allergic to dogs, it's my.
Right, Rich, huh?
And he's cleaner than.
I tried.
No.
Very
Really good, thanks.
And if you were to watch, if I've got these puzzles. You have to move it this way, then move it down.
Mhm.
First time it took him about 15 minutes. Now he can do them all in about 5.
And what kind of design?
Wow.
It's a plastic thing, looks like a giant etch-a-sketch,
Yeah.
but with compartments. And there's an empty one that you have to move this down and that
One of
over
those like,
in order to get into the little.
but what
wall.
does the picture look like if the dog wants to see?
Well, the picture he wants to see, I think he likes to, get his own.
Okay.
Because it'll have.
Understand, and then they can just figure it out.
Okay, so it's,
To get moving.
I thought the puzzle meant it puts together a picture, and I'm thinking,
No,
It's findings.
it's.
Learning how to focus. Enjoying.
Oh, thanks for starting that up.
Enjoying that one, far more complicated one.
We'll see.
Which is a simple thing, and you have. Full longer.
You could add
Move these,
It's hard not to. Really?
yes. I've actually. My previous. I was very my. In 3 point.
no, you let them just figure it out themselves.
Well, I'll tell you the story eventually. I was the only person working in a lab and the only dog running there, and we have to drive like these two.
You've been directed.
I can't do that, but I got candy was. And then I found one still on a shoebox. And I took that shoebox and got rid of the refrigerator. And apparently over a month period. Over a month period, we had, stashed all the candy wrappers, or many of the candy wrappers under his bed. Getting up to the.
Glad we're connected to the right black cord.
And.
Oh, that could be it.
You would actually put the top of the shoe.
No, I think you need this one.
And close the door. And then to the computer. Then you basically, you could Three-stage operation. Yeah.
Yeah, it's not.
I was embedded with psychologist.
Let me see. There we go.
My dogs.
Thank you very much.
In my office. I ordered a. Well, it's kind of it's 35. So it's taking a lot to get solved. Classic wall with the final mirror. No, it's still there.
Right, maybe not.
Well, that was no problem. Next thing is. Before the mirror.
Well, we'll start in about 15 seconds, if that's okay. You want to get a donut or some Kringle? It's in the back. Our speaker, Jaime Cordova, is on the way here, but he should be arriving in 15 to 20 minutes, I hope. And when he told me that he had to arrive a little late, I said, that's all right. I'd give a travel log because I didn't get through my talk last week. Do you have any questions on the what I talked about last week? So as a reminder, I'm Tom Zinnan. I work at the University of Wisconsin Madison Biotechnology Center. I also work for the Division of Extension Wisconsin 4-H. And last week here at PLATO Frontiers in Life Sciences, I gave a talk on the summer 2022 recovery mission by the UW-Madison Biotechnology Center's Missing in Action Recovery and Identification Program, which is a program that looks for the remains of missing U.S. servicemen, tries to identify those remains, and then if they're successful, they are able to shift a missing in action service member from the MIA roles to the known roles, and then give an appropriate burial to the
So how
remains.
much bone do they find for these people, and then they call it?
Enough to get DNA out of it and identify, and it can
Yes.
be a small amount. Sometimes that's, given the fact that the first, let's see, 3 of the 4 missions have involved pilots going down on or pilots or crew members going down on in a plane crash. So there may not be a whole lot of remains. So now I'm going to give you a little travel log. For a little bit of background, our mission ran from June 27th until July 15th, and then we had a couple of days to travel. We also traveled and visited places on our day off, which was Sundays. And one of the things that I like to keep at the front of my mind is it may have been a horrific war for Americans, but it was far more horrific for the folks where the battles were fought on their own backyards and front yards and in their houses and farms. This is a monument in Belgium to remind us that Belgium has seen lots and lots of wars in the 20th century, World War I, World War II, and then this little thing down here, I thought was really poignant, 50 years of peace, thank you. And so 50 years would have been 1995, this is 2022, so that's 27 years ago. So we visited Bastone, Luxembourg City, Arlon, and Ardennes. And there'll be some pictures in here from that. Some are just because they're pretty, some help give context to the mission that we were on. So this is the city center, the McAuliffe Square, named for the commanding general of the 101st Airborne, which was the airborne unit that had occupied the city of Bastone as a crossroads city and was there when the Germans invaded or started their counterattack in December 16th of 1944. Bastone was completely destroyed, so all the buildings you see here are in the style of what was there before, but they're buildings that had to be rebuilt after 1945. And this looks pretty great coming in from up front, and then you walk around here and you see that this tank was most likely disabled by this shell. And it just reminds me of, if I was a tank crew member, I'd think, man, I'm doing all right. At least the bullets won't get me, but you're still vulnerable. This is the restaurant where we went to for lunch. It's called Le Nuts, and you may remember that when the German general submitted a written demand for surrender to General McAuliffe, McAuliffe replied in writing with a single word, nuts, N-U-T-S. That's part of the lore of the 101st Airborne and the lore of the Battle of the Bulge. And so we're pretty familiar with this. In 2001, Steven Spielberg and Tom Hanks and others put out this series called Band of Brothers, which was based on the book by Stephen Ambrose, who was born and raised in Whitewater and who went to college at the University of Wisconsin and played on the Rose Bowl team, which I think was a 1962 Rose Bowl team. If you want to see Stephen Ambrose as a young man, watch The World at War, which came out in 1973 that was a pivotal documentary in my family's life. And just go online sometime and see Stephen Ambrose as somebody who was probably in his mid to late 30s, if not younger. This gentleman here was one of the actors, and of course this was filmed 20 years ago, who played one of the soldiers in the 101st Airborne and the Easy Company that is featured in this. And part of what he does now is he helps lead tours of Bastone and this area, and somebody recognized him. And so many of the folks on the crew asked if they could get a picture with this actor. So that's what's going on there. This is a monument at one of the 3 museums that we went to in Bastone. This is in French, by the Belgians, for the Belgians, to our dead, 1914 to 1918, 1940 to 1945. Glory to our dead. And I can't read this, it's too small, but I think it tells what outfits were involved there. And this is a big deal for me. This is from the Bastone Barracks Museum. And if you read this here, it's actually a reproduction from printed much later, but it was something that was produced during World War II. And these are the kinds of planes that we were looking for. I can't tell you what type of plane the team knows, but we're not supposed to divulge that until such time that we have an identification of the missing in action person that we were looking for. The Thunderbolt was a key fighter plane. It was called P because we used to call them pursuits. That was the plane that both Lieutenant Fazekas and Walter Stone were flying, and those were number 2 and number 3 in the series of 4 recovery missions that the UWMIA Recovery and Identification Program have gone on. So this one, the P-47, was a type of plane that I worked on as part of the team's dig in 2016 in Busquier, France. And then the bomber was going to be either a B-24 Liberator, a B-25 Mitchell, a B-26, which I don't see on here, or a B-17. So those were all multi-crew bombers that were flying over Belgium. The one you don't see is the B-29 because B-29s are almost exclusively, with the exception of one, which I think was used for reconnaissance, all the B-29s were used either in Burma, India, China, or then in the Pacific Islands in order to bomb Japan, the home islands. This was great to see up close because of the ducts that are used at Wisconsin Dells. One of the key things around in getting from France up into the Low Countries and then into Germany was having to cross a series of bridges and swampy areas. And so having these kinds of amphibious vehicles, this one has both a propeller and tires, so it can run on land and run on water, and people in Wisconsin know this pretty well because of the Dells. But this is pretty cool because this is how you could shuttle units of soldiers back and forth across minor or major rivers before the bridges were there. Of course, then they wouldn't have much in the way of mechanized support or tanks, but at least you could get around. This is another war museum called the Bastone War Museum. It's different from the Bastone Barracks Museum. This one is on the edge of town. Bastone Barracks is downtown. This one is newer, and that's where this was put up. I'm going to try to read a little bit of this in French. This was one of the more chilling posters I've ever had the chance to read. It says the field commander of the German army in Brussels communicates the following. On the evening of the 16th of December, criminal hand put against the facade of a military building on the Avenue Louise in Brussels, a bomb or an engine which an exploding would have caused considerable damage, material damage. I don't know what circumstance of gravant means, but on the night of the 15th to the 16th, 3 electrical transformers in the area of Vilvoorde were damaged gravely by explosives. The entire population is invited to aid in the discovery of the authors of these criminal attacks and to let us know immediately all information that might aid in their arrest by going to either the Bureau of Police of the Belgians or to a German army post. If the guilty parties are not discovered by the December 27th at midday, is that right, Meady? Yeah. A certain number of Belgians who have already committed grave acts of sabotage will be considered responsible of these facts, and therefore they will be shot. So it's kind of sobering what the civilians were under. Not only were they have to worry about being bombed by stray bombs from the Americans or the British, artillery, gunfire, and worry about getting shot. And this is in part how some of the Belgians remember this time. In the spring of '44, bombardment by the Allies, both by air, then the attack by the British coming up, the Canadians on the left, the British in the center, and the Americans to the right, to the south, heading towards Luxembourg. Then this is from the New York Times from Friday, December 29th. This is 13 days into what we call the Battle of the Bulge. And what's interesting about this is all the different things I saw going on here. This is what most people would now consider late in the war. Of course, we didn't know on December 29th what 1944, what 45 would bring. If you remember that the Army seized Montgomery wards in Chicago for not cooperating with the war movement, the war program. We're already seeing the idea of what Churchill would call in 1946 an Iron Curtain, with this little headline here called Soviet Domination of Austria is seen. Patton's Third Army sent. So this is, I can't see the rest because this is part of an exhibit. But of course, Patton's Army, the Third Army, is given great credit to the chagrin of the 101st Airborne for coming up and relieving the 101st Airborne, which I don't think the 101st Airborne would ever use the word relieve. So this is how this was covered. And the number of stories above the fold on the front page is just astonishing to me. And notice that the word bulge is not here. They use the British word from World War I and other wars, salient. So if you've ever heard of a sally port, the sally port is a door in a castle or something, and it's how you sneak out to sally forth. And if you see the word bulge on here, let me know. Because for the most part, the Battle of the Bulge was fought under the name of the Battle of the Ardennes, which is how the Europeans still call it. Now this is Stars and Stripes, which is the Army newspaper. And this is from January 4th of 1945. So the previous one was December 29th, if I remember correctly. This is January 4th. And here is the earliest I've ever seen. Doesn't mean it wasn't used earlier, but Stars and Stripes now is calling this the Bulge. So how these names of battles get sparked and whether they stick or not is pretty interesting to me. I grew up reading The Brass Ring by Bill Malden. If you remember him, he was the cartoonist for the Chicago Sun-Times. When I was growing up, he famously made the cartoon of the statue of Abraham Lincoln from the Lincoln Memorial, putting his face in his hands when John F. Kennedy was assassinated. And I think he won the Pulitzer Prize for cartooning that year. He got his start with the Stars and Stripes in Italy, not in France. So this is at the 101st Airborne Museum in Bastone. This is back in the city center. And this is showing on a map table all the different movements in this month-long attack by the Germans, the counterattack by the Canadians, British, Americans, and especially the Americans for the Battle of the Bulge, because it was the American sector that they were attacking. As a reminder, this is Tristan, and he's getting his PhD at Texas A&M University, and has been part of the team at least for 2 years. And this is Ryan Rubin. He's a physician, an ER doc, and a professor in the ER department here. He's also a pilot, and his undergraduate degree is in archaeology. And this is in English in Luxembourg City. And one, it struck me when it's in English, the Luxembourgese are as multi-language as any place I've ever been. But they did the courtesy of putting this up in English because it's commemorating a US armored division. And so this is in the fall. We had 3 months and 6 days to go until the counterattack by the Germans. And this reminded me that Americans had been there before, and that Luxembourgers even have books about this, and that in many ways World War II had a great deal of deja vu with World War I. This is the major monument that you see when you first walk into the American Military Cemetery in Luxembourg City. And this is designed and built, and I think paid for by the United States. The land was signed over by the Luxembourg folks. But what struck me about this is, for a nation that is officially not religious or has no official religion, they do this very interesting thing of having some very Christian memes to it. So here we have this figure, I'm guessing is an angel, but it's raising his hands, a Catholic altar boy that looks a lot like something I've seen before. And then here is the what I would call an altar with a cross, and I give unto them eternal life, and they shall never perish. So I was very intrigued by this. It's very different than, say, if you've been to Arlington National Cemetery. It's not the same vibe that I get at Arlington. It says, grant us grace fearlessly to contend against evil and to make no peace with oppression. So what got interesting to me about this is that here's this wonderful woman who's an American, but speaks several languages and lives there now. And she's going to talk with us about the gravestones. First and foremost, you'll notice it's in the shape of a cross. So when you see Saving Private Ryan, that's one of the opening scenes, as these are almost all crosses, and every now and then there's a Star of David. If you go to Arlington National Cemetery, what do you see? It's a headstone that's like this. And I was struck by this because it's the first time I've ever been in a place where the headstones are like this. And it says, a comrade unknown, in arms unknown, but to God. So this is an MIA whose remains are there, but the identification is not known. The flag is at a half staff that day because just previously, Shinzo Abe of Japan, who was the former prime minister and the longest serving prime minister of Japan, had been assassinated. And the irony, to me, of the United States flag flying at half staff in honor of a prime minister of our enemy in World War II speaks well of how the two nations have been getting along since 1945, 1946. And then this is one of the things that this is why I'm interested in this. Here is a Star of David. So this person was Jewish, not Christian. He's also and how religion played a significant role in this war, especially in Europe, especially where you had fascists whose one of their prime objectives was to rid the world of Jews and other people that were in groups that they didn't like. But in this case, we're talking especially about Jews. So the woman said to me, said to the group, well, keep in mind when you were in the United States Army or Air Force, which was part of the Army or the Navy or the Marines or wherever, when you got your dog tags and you filled out your information that was going to go on the dog tags, you had a total of 3 choices under religion: Catholic, Protestant, and Jewish. There's no atheist, there's no Sikh, there's no Muslim, there's just those 3. So if you're Jewish and you're going to fight in Europe and you might become a prisoner of war, that might give you pause. And so these are each one of these things has a specific number that identifies that. Well, let me go back to this so that I can finish this story. So one of the things that the folks that run the museum are doing, the cemetery are doing now is going back through the records and finding soldiers that ticked the Protestant or Catholic box, but actually were not just Jewish, but were by culture, but were practicing Jews. And if they can get sufficient evidence that this is a practicing Jew who ticked the box for that, they will go and change the headstone from a cross to a Star of David. And 3 days earlier, when we were there, they had just done that with one of the headstones. I think this is a very interesting thing. I don't know that this had to happen for the cemeteries in the Pacific, because I don't know if it was an issue in Japanese controlled areas, but it's a very intriguing thing that this is how we have our headstones. And it's very different than Arlington National Cemetery. So you may know that the most famous person buried at the Luxembourg American Military Cemetery is George Patton, who died not in 1944 or in the first half of 1945 during the war, but in December of 1945 from injury suffered in a car wreck. So it happens that the rules are, you can be buried in this military cemetery if you died before the end of 1945. So Patton is buried there. This person is one of the few, if not the only woman that's buried at the cemetery. She was a nurse, and in July of 45, she was on her way to rendezvous with her sister, and she was in a car wreck and she was killed. And that's why if you can see this, this is her date of death was July 24th, 1945. And to me, this is one of the things that was great about having an excellent guide, to be able to point out these poignant stories. I'm just trying to imagine being in this war zone, living through the war, and then being one of the people that dies of a car wreck on your way to see your sister. So that was Nancy J. Leo. She was a second lieutenant, killed on the 24th of July, 1945. This says the 26 American Battle Monument cemeteries hold the remains of 70 women that died during World War I and 111 that died in service in World War II. I'm not sure. I'm not sure how many women are buried there, but in Luxembourg, but it's a very low number, and she is one of them, if not the sole one. So this is the guide telling us the story about this gentleman, who was the person that they had just recently switched over from having a headstone in the shape of a cross to the headstone in the shape of a Star of David. Now, I don't know, and I probably should look it up, but it would be very interesting to know what the options are now if you're in the armed forces, and how many boxes there are that you can tick, and what kind of headstones are provided. So this is Patton's grave. When he was first buried there, he was buried among everybody else, but so many people came to see Patton's grave that there was too much traffic and damage to the turf. And so the decision was made to put him off where they could have a specific place. Lots of people could walk there without ruining the cemetery grounds by going where there wasn't a sidewalk. The other thing is, he's the only one that I saw that has black letters. I don't know, and it's okay. I had no indication that this was designed by anything but by Americans. So when you asked me who designed, I was trying to think of the architect, but this is American Battlefield Monument folks. Now, this is one of my personal pilgrimages. 1986 was the first time I went to Europe. I flew on Icelandic Air. And at that time, if you flew very cheaply in Icelandic Air with its 16.5-inch wide seats, which I could fit in at the time, you landed at Luxembourg City. And so this is the city that I spent my first jet lag day in. And walking around, I'm walking around the city center, da, 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 this is cool, this is cool. And I look up and there's my name, my family name. And this is almost identical to a picture that I took in July of 1986. It says, to the memory of J. Antoine Zinnon, composer of the national hymn, Our Homeland, 1827 to 1898. And so going back to Belgium and having the chance to go to Luxembourg and to Luxembourg City, I wanted to find where this was because I couldn't remember where it was, and I found it and I was happy. Yay.
Is he related, you know?
Is he related to me? Am I related to him?
You haven't proven that, or?
No, I have no idea. For his sake, you can hope that maybe he's not related to me. Staying on the family tree. And then this was another sobering thing. This is 1.5 miles from the American cemetery. This is the German cemetery, military cemetery. So look at the, compare and contrast the German cemetery and the American cemetery. So to get into this, you go through this very tight gate. And then it opens into a field. And there are lots and lots of trees. If there are trees at any of the battlefield cemeteries in Europe, I don't remember any pictures of them among the graves. And then you don't get your own headstone. There are 2 on the front and 2 on the back. So you get 4 people per gravestone. And then I was looking at the ages and how old or how young these folks were, because it's late in the war, especially if you started in 1939. And you're looking here at March 2nd, is that, do they know? That's the 3rd of February, 45. They do day, month, year. So this person, Heinrich, is 36, no, 38 on at least in his 38th year. And this guy is 43 from 02 to 45. And this fellow is very young. Carl Haig was 19. I'm doing the math right. And then this is the story. It's in 4 languages. I took the picture of the English version and the years that it took to be able to figure out what are we going to do about the remains of the enemy. Again, this is the 2nd time the Belgians have had to deal with this, 1918 and then 1945. So they were 5,286 war casualties scattered at 150 locations in Luxembourg, and Luxembourg isn't that big. So they condensed many of them, and so the place that I was at had 10,900 soldiers there, and this was 10 years after the end of the war, 5th of June in 1955. The dead of this cemetery admonished peace. So the whole tone, of course, is very different. When I was in France in 2016, I got to do that, got to do the same thing. We went to Commonwealth graves, which is the British, Canadians, the Australians, New Zealanders, the Indians, South Africans, the entire British Commonwealth, and then an American set of graves, and then the German cemeteries. All right, so I think I took these just so that you could read that more. So I'm hoping that Jaime will be here soon. Let me see if I can find out if he's sent me a message.
Hey, Tom, I'm about 5 minutes away. I don't know if you can hear me.
Yes.
You know, unknown soldiers graves. Now we got DNA. Has there been any thought about resurrecting them and finding their identity?
The US at Arlington has an unknown from World War I, World War II, Korea, and there's an empty grave, a cenotaph for Vietnam. And at one time there were remains in the one in Vietnam. And I don't know how many years ago, but it's been a while. But the DNA technology had developed sufficiently that the folks that do these kind of detective work had a pretty good idea who might be the unknown for Vietnam. And they got permission to exhume the remains, sample the remains, test them with DNA. That was able to confirm the identification, the identity of the remains. And so those remains were given a full burial and with the name of the person at another site, another burial site. So there's still a cenotaph, an unknown there, but it's an empty grave. The other three, World War I, World War II, and Korea, have remains in them. I don't know that there's any impetus to try to identify.
Those other graveyards, though, got just common graves that say unknown. And not the memorial, but just regular cemetery plots that say unknown. Seen them.
So I'm not sure what the strategies are, but clearly that's one of the things that would be possible is to, if that were a policy that people thought was appropriate, would be to exhume the remains, take samples, run the DNA fingerprinting, look for relatives that might be grandchildren, grandnieces, grandnephews that have had their 22 or 23andMe or any of the other things that are now considered public. So that's a possibility.
That's a real complicated ethical issue, right?
I'm speaking very slowly because it's a very complicated issue.
I
Yeah,
don't know who it is, so you have no, you can't get family with Google.
correct.
And then you
On the
can
other hand, it's,
identify it, and it says, you know.
yes, so,
do that.
You know, under the military code of justice, they basically can do whatever they can.
Oh, they can.
And the civil rights of are suspended and maintained.
so yes, it's, as you're mentioning, the military code of military uniform code, military code of uniform justice and ethical issues. And this is why the other thing that's advanced is the technology for identification. There are very few unknown remains from Vietnam to begin with. I don't know how many are unknown now. They're missing, but I don't know how many remains that we have in the last 30 years that have not been identified because of the DNA technology. So one of the questions will be is how far back do we choose to go? Korea, World War II, World War I. But keep in mind that at the Battle of something field, Blyden Field, where was Richard III killed? Bosworth, thank you. And that was 1485, 1486. And remember when they found the remains of the king in the car park? And so that's in the last 10, 12 years, I think. And they were able to find at least somebody on the paternal side, I think a person from Canada that was part of the line that they were able to trace using genealogy. So if you can do it over 600 years, 500 years, let's just call it 500 years. As you're pointing out, it's like, wow, this is,
Today's papers have been found a Korean soldier identified. From prisoner war camps.
yes.
Is there any desire to look for cavalry from the Indian Wars in the last century?
I don't know that.
Taking pictures of cavalry stones, and usually they're just buried outside the cemetery.
Yeah. So the question is, is there any interest in identifying US cavalry soldiers, unknowns from the US Indian Wars in the late 19th century? And I don't know that, but if you can find the remains, that's a possibility. How's it going, Jaime? Good. No, you're doing all right. I entertain them. Look at them.
Awesome.
At least half of them are still awake.
Yeah.
That's because I pumped them full of donuts. Okay, so if you wanna, you can either transfer over to mine, or you can, why don't you fire it up and then we'll switch it over.
Okay.
So another place we got to go see was this Archaeological Museum of Arlon. Arlon's famous because they found a whole bunch of Roman stuff there, which is pretty cool. And for somebody who was looking for human remains for 3 weeks, this is not anything. This just goes to show, wow, that's a 1800-year-old set of bones. And as I'm sitting there digging or shaking, I'm thinking, this was 78 years ago. How is a bone going to survive? And then you go see this, and it's like, well, it might do better than not. And then this is the Ardennes cemetery that's distinct from the Luxembourg cemetery. And the numbers here and below are the ones that are impressive to me. I'm going to show you close-up pictures of those. So this is the number of burials in the World War I cemeteries in Europe. And the number of missing. Here are the numbers from World War II. And we're at Ardennes, and we were at Luxembourg. My dad served in the Army, and the Army very courteously sent him to Manila. Luckily, they sent him to Manila in April, and he wasn't there for the very devastating retaking of the city of Manila from December through March. There was not much left of Manila, but that is a very large number of folks. And then the one that also surprised me was this one, that the building of the Panama Canal, there are 5,000 burials in the 12 years, 14 years it took to build the canal. You don't hear about that very often. And why they're buried in a military cemetery, I don't know, but I was struck by that. Okay, how's it looking, Jaime? So I'm going to stop there. So the folks that are watching at home or whatever, we're going to switch over. Able to your screen. probably.
All right. So, as Tom said, my project is focused on trying to understand the response to oxygen in bacteria. And we'll talk a little bit about a little bit over this. So, starting off, going way back when, about 4 billion years ago, the Earth started forming. Obviously, it was an anaerobic environment. There was no oxygen out in the. There was no oxygen in our atmosphere. And in fact, molecular oxygen is very rare, surprisingly. It wasn't until about 2.4 billion years ago where these little bacteria, cyanobacteria, started basically showing up in the ocean, some of the earliest forms of life, and started producing enough oxygen. Around 2.4 billion years ago, they produced enough oxygen that it was able to escape the ocean and give us the planet that we have now. So at about 2.4 billion years ago, I'm sure you heard of the Great Oxidation Event. Not only did it kill off all of the bacteria, or I'm sorry, all of the organisms that are anaerobic, so needed the absence of oxygen to survive, but it also gave life the opportunity to become more complex and to evolve to be able to grow in a now aerobic environment. So what we see today is we see aerobes, which require the presence of oxygen, just like us. We see anaerobes that require the absence of oxygen. And then of my personal interest, we see facultative anaerobes, which can survive both in the presence or in the absence of oxygen. These are the, like I said, the organisms that I study. The particular set of bacteria that I studied are from the family of Enterobacteriaceae. You may have heard of this is because E. coli and Salmonella belong to this particular family. We know that E. coli and Salmonella obviously get a very bad rep because if you eat, bad meat, or if you, eat raw cookie dough, you're at risk of getting either E. coli or Salmonella. They're part of a large family of gram-negative bacteria. Most of the Enterobacteriaceae organisms are facultative anaerobes. And as I mentioned, they're made up of both non-pathogenic and pathogenic bacteria. So they get all the bad reps, right, are the ones that we hear of the most, but we actually have E. coli that naturally survive it. And what I'm focusing on is, as I mentioned, from the Enterobacteriaceae family, are E. coli and Salmonella that diverge approximately 140. So we're looking at about 140 million of evolutionary. So where are Enterobacteriaceae found? We can find them naturally in the dirt. We can also find them in water sources. If we travel to other countries, we may often fear the risk of just drink bottled water. You don't want to drink tap water or water from other sources. And as I mentioned, at least Salmonella, or I'm sorry, not Salmonella, at least E. coli and a couple of other different bacteria, Enterobacteriaceae, are naturally found in our gut and help, make up our gut microbiome. And unfortunately, some of those can go a little rogue, end up with, UTIs or a variety of other diseases. So the response to facultative anaerobes to oxygen is really important to understand for a couple of reasons. At least from a health perspective, each year the United States, about from quote unquote bad E. coli or pathogenic E. coli, you're seeing about 205,000, about 100. Again, that's in the U.S. alone, and numbers throughout the world. And from Salmonella, you see that number increase to about 1.35 million down to about 100 deaths. And we know that virulence, or basically what makes bacteria pathogenic, and how they adhere to the host, whether it be us, whether it be other mammals, or whether, for example, Salmonella, avians or reptiles. We know that that response, how sick they can make you is linked to oxygen levels. And as Tom mentioned, I also have a big interest in astrobiology. So, which, if you're not familiar with what astrobiology is, it's basically trying to understand the origin of life here on Earth, or potentially elsewhere, the evolution of life, and also the search for life elsewhere in our universe. So the reason why this project, and just really any basic science project in general, where we're trying to understand bacteria, it's important for how we look for life elsewhere, because by understanding life here, it allows us to hypothesize where in the universe life may be able to actually survive, and where we should be looking, whether it be, for example, here on Earth, based on the life that we know here on Earth, we're not going to go look on Mars. We're probably going to look on Mars, or arguably, and a lot of people agree with me, because there's a handful of sort of crazy delusions in the clouds of Venus. So yeah, so those are a couple of things. Now, an example when Salmonella experiences varying oxygen, I like to use this example from 2020, where there was a case of Salmonella outbreak from red onions, and made people, at least at the time that I took the screenshot, of the sick across 31 states. And this is a perfect example, because when these red onions are growing out in the field, they're contaminated with the Salmonella. Well, the Salmonella are growing in an aerobic environment, obviously, right? They're continuing to be in an aerobic environment until they get either to the grocery store, or and then eventually to your kitchen, things like that. You cut up these red onions, put them in your chili, put them in whatever you want to put it in, and you consume those. And now those bacteria are now in an aerobic environment in your gut. So they've had to now adapt to be able to survive in that anaerobic environment, change which genes are being expressed, to be able to, again, to survive in that environment. Well, if there's enough of it, you're going to get sick, and it's going to come out either way, the back end or the front end, and well, now they're in an aerobic environment again, right? So now they've had to adapt to be able to be in an aerobic environment. Now, one of the probably biggest or most important bacteria, and coli K12MG. And I like to call this a workhorse and a wimp. Jokingly, I like to tell people that the purpose of my PhD project is to trash on E. coli K12, and you'll see why. That's not really the purpose of it, but in a way it is. So E. coli K12 and K5 was isolated from school sample out in Stanford in 1922. It was quote unquote designed to be harmless to humans. And what I mean by design is that, it went through a lot of processes and eventually also lost what basically made it pathogenic. So in other words, the goal of it was if this particular strain got out into the world, or got out of the lab, then it wouldn't be, and especially for those people who work with. So this is, for example, a common strain that you see high school students work with, and is a very common lab strain. The genome was first sequenced in 1997 here at Madison by Fred Blattner lab, who part of the Blattner lab is my PI, Nicole Perna. And as I mentioned, it's a workhorse for molecular biology. So E. coli K12 has been used in almost everything that you can possibly think of, whether it be introducing plasmids to other bacteria, introducing plasmids to plants, you name it. E. coli K12 has probably been at least placed on the market. And it's likely the most studied bacteria. So it is a model organism. Now, because it's a model organism, that's where it sort of becomes challenging. It is, like I said, the most studied bacterium. It's used as its knowledge, or the knowledge that we get from it, because all other bacteria. But the question is, should we only focus on one side? And that's in a way the purpose of my goal, or of my project. So just to give you an overview of my project, we want to understand growth differences in aerobic and anaerobic conditions in E. coli strains. We're trying to understand the genomic variation. So basically, the genes are responsible for the growth differences in the E. coli strain. We're trying to understand the conservation of the oxygen responsive genes across all those strains. Some of these strains come from lettuce, some of these come from humans, some of these come from cows. So we have a really wide distribution of sources of these strains. And then ultimately, and probably most interesting, at least to me, is trying to understand the evolutionary history of these oxygen. So like I mentioned, the motivation behind the project is we're trying to develop knowledge for other bacterial strains species from E. coli K12 and what we know so far about the oxygen responsive subsystems, or basically the molecular, the subsystems and genetics behind the oxygen responsive E. coli K12, we see different regulatory systems, including, for example, DNA transcription. We see toxicity, we see pH and acid stress responses. And we also see, and probably most importantly, and probably most obvious, we see changes in its metabolism, whether that be glycolysis, PCA, or a variety of metabolic processes. But in the first 2 years of my work, we found that the response to oxygen to different oxygen levels is not necessarily equal amongst all of our strains. And that's probably been the biggest motivation of the project. So the first question is how much environmentally responsive regulatory variation is present within and between our 12. And the way that we do this is that we measure growth rates. Very simple experiment. Basically, what we're doing is we grow our bacteria to start off in aerobic conditions, get them to adjust right out of the freezer because they're stored in -80 degrees Celsius to contain stream. And what we do is eventually we grow this in a particular media that basically just provides them just the bare minimum of nutrients that they require and a little bit of food to help them out. And at that point, we're growing these either in aerobic conditions or anaerobic conditions. And I wish I had put them in a picture. I realized that I couldn't. Basically, look at aerobic conditions. Very simple. If you've ever seen a chamber, it looks almost like a fridge, and we keep it at 37 degrees. Just pop the plates in there. But for anaerobic conditions, what we do is we have a anaerobic chamber that basically is inside is there is little to no oxygen, and the way that we are able to transfer our material in there or our samples in there, we open up we essentially have why am I forgetting the word? We essentially have an airlock. We have an airlock on the side. All of the oxygen is vacuumed out and is replaced with nitrogen and a mix of carbon dioxide as well. And then we're able to pass that in. So right off the bat, they're in an anaerobic state. Once we do that, we are able to measure their growth for overnight, and then able to compare the aerobic versus anaerobic rates for each of these strains. Now, this is a very big big and heavy data filled graph, but I'll walk you through it. Basically, what we're looking for, and I think I should have mentioned, or I don't know if I mentioned, but for the purpose of this presentation, I'm solely focused on E. coli, not salmonella. What we're seeing here is these are all of our E. coli strains on the x-axis. What you're seeing is the aerobic growth rate. On the y-axis, you're seeing the anaerobic growth rate. And what we're seeing is that in general, there seems to be a positive correlation in growth rates between aerobic and anaerobic environments. And basically what I mean by that is in general, if they are a good aerobe, meaning that they grow well in an aerobic environment, then they tend to be a good anaerobe, and they grow well in an anaerobic environment. One of the other things that we see is for those that you see here in blue, we see a high amount of variation in a short period of time. So these are the 01577 strains of E. coli. 01577 are probably are the most famous, at least for the general or for the wider public, because these are the ones that are pathogenic, or some of the ones that are pathogenic that have been responsible for several outbreaks throughout the years. But they only diverged from the rest of the E. coli about 5 million years ago. And interestingly, we're seeing a lot of variation in a short amount of time, which is one area that we're interested in looking at. Why are we seeing that much variation in our growth? And probably most interestingly, we see a divergence of K12 and G1655 from the overall trend, from the overall growth rate trend of the other E. coli. So you see how, we've got all this nice trend, most of them tend to be up here. Well, E. coli is the K12. And again, so the E. coli K12 has been used as a workforce, and it's designed against it in a sense to be a win. But this has really motivated me and motivated the project of, well, should we really just be applying the knowledge from K12 right off the bat to everyone? Right? It's an okay aerobe, and it's a sort of mediocre anaerobe. And the reason why there's two is that here there's actually two strains of K12. One is MG1655, the other is another strain of W. And basically, what we hypothesized from this, which I'll touch a little bit more on later, is we believe that the reason why we're seeing a decent amount of variation, but not a huge amount. If you look at our x-axis or at our axes, you see that we're going up to 0.0195 here, 0.0135, and these growth rates tend to stay small. But we're not seeing a huge amount of variation. And what we're predicting, or what we hypothesize is that more than likely the genetic variation that is actually in these strains likely lies not in an actually oxygen responsive subsystems, but more than likely is in some other common systems, which again I'll touch on a little bit later on, and that's why we're getting some variation. So the next portion is how much variation are we actually seeing in these strains, right? So what we did, or what I've done, is I did a pangenome analysis. And if you're not familiar with what a pangenome is, or actually what a pangenome is it essentially is a type of analysis that allows us to take into account the entire set of all of the genes in all of our strains. So basically what I mean is K12MG1655 has 4,000 genes, and W3110 has 3,000 genes. Well, the pangenome for that is 7,000. And we're looking at this across 158 strains. And what we found is that there are over 12,000, or about 12,236 genes found across all of our genomes. And most genes, interestingly enough, are in what are known as the cloud gene. And what I mean by that, so here I'm showing the cloud genome, again, about 54%. What the cloud genome is, it means that it's in less than 23 of our strains, with usually the most important that people focus on is the 4 genome, which is only made up of about 12% of those genes. So that means that they're present in 156 to 158 of our strains. So basically what this is telling us is that there is a lot of variation amongst our E. coli strains, which is in a way to be expected because we're looking at so many, but it's also a little unexpected because they're all within the E. coli family. They're generally very closely related. And as I mentioned, the 4 genome is made up of 1,440 genes. Now, when we look at that 4 genome and focusing specifically on what may be oxygen related, as I mentioned, metabolism is probably the biggest focus of that, or is usually what's most associated with that oxygen response. And we see that about 537, or approximately 37% of the genes that are in the core genome are metabolism related. Now, the reason why this is a little difficult, actually, I'll talk a little bit. But yeah, so what we're seeing, 10% from, as I mentioned, ion transport metabolism, energy production conversion, 9%, things like that, and so on and so forth. Now, where do the oxygen responsive genes fall in the pen genome? Now, the reason, this is where it gets a little difficult. And the reason behind that is because majority of the data of the oxygen response that I mentioned comes from the folate H12NG5. I'm using a particular study that was done here at UW-Madison back in 2013, where 636 genes were identified as oxygen responsive. 84% of these are present in most or all of our strains. But the question is, yeah, all right, cool, those 84%, and that we know that those are in H12NG1655. We can associate with that, with those genes. But what's making up the response in the other 16%? There you go. Yeah, so basically what I mean, by that is if they are in aerobic conditions, we see a different gene expression compared to what we see in anaerobic conditions and vice versa. It would in a way, yes. Yeah, so in a way, looking at the genetic architecture behind the changes. Yeah. Are there other questions? And feel free to stop me if we're going on. So again, what's making up that other 16% that's not in K12MG1655? And what does that response look like in other strains? Because again, the majority of the data, you look at it and there's MG1655 and maybe one or two other strains, at least related to the oxygen response. Not a lot of information, or not a lot of studies have been done across other strains. So the question now is, because before we get into, the way that we would do this is a process known as RNA sequencing. Basically, what we do there is we collect these, we grow these bacteria in whatever media and in whatever condition we're interested in. We grow them, we extract their RNA, which acts as a proxy for their gene expression levels, and that tells us, okay, well, gene A, which is responsible for growth in aerobic conditions, is increased in aerobic conditions, and is decreased. Okay, well, so we have to do that, or ideally, we would do that across all of our strains. I'll tell you right now that was naively my goal when I first started out. This project, to do RNA sequencing for 158 strains, or actually 182 strains, so including my son out. That costs as much as a house. It's about the price of mortgage. Usually about $600,000. I don't have that kind of it would be lovely, but we don't. So, and it's fine. I mean, honestly, sometimes that's probably more data than that's probably 3 PhDs worth of data. So I'm actually kind of glad that we don't have. So the other way that we go about this, and actually also sort of a precursor to that, is we look at the genetic variation that's affecting the growth rates in aerobic and anaerobic conditions. We use a different process known as GWAS. Basically, what GWAS is known as a genome-wide association study. And what we're doing there, this has primarily been used for humans, and we've been recently introduced to do these kinds of studies in bacteria, or in microbes, I should say, is what we're trying to do is calculate associations between the genome or the genes that are in these strains and whatever phenotype or whatever visual you see. In this case, it would be their growth rates in aerobic conditions and anaerobic conditions. Now you'll notice here that I mentioned the association between excessive and the core genome or not entirely. Now the reason behind that is because the core genome includes K12NG1655. So we already know what genes are associated with that in all of our other strains. No reason for me to focus on that right now. I'm interested in the ones that are not in all of the genes that are present in 155 strains and below. So, and the reason again why we're doing this is it gives us an initial prediction of the genes that are possibly responsible for that oxygen response in the other strains. This is not, again, meant for you to be able to see everything that's going on here. But basically what I want to show you, so these are all of the strains that I'm working with, 158 E. coli strains. And I should mention that this covers all of the E. coli phylogenies. In E. coli, there are 4 main phylogenies, which basically means that we look at the phylogenetic tree, looking at particular genes, we can assign them how related they are to other and categorize them that. So in this pan-GWAS, what we found is that in aerobic conditions, we identified about 241 genes that were associated with those growth. Interestingly enough, and you may be able to tell, these are probably the most interesting to me. So these are span about 4 phylo groups out of the 6 that are included in here. But you can see that why do these guys have this and these sets of genes and the other guys don't? That's probably so that question came up later on, and I'll talk a little bit about that in a bit. What we noticed is about 48 of the 48 of the 241 genes were associated with metabolism. And actually, all right, so in anaerobic conditions, we saw very similar trends with the same set of strains that you can see here in these phylo groups. We also see a presence of some, I believe, 50 genes or so that aren't present in the rest of the in the rest of our strains. Why are they there? What are they responsible for? That's one of the new questions that came up when I recently did this analysis. And now, what we did in anaerobic conditions, we found about the same percentage, 145. Obviously, the number is greater. We found about 23% of those genes could be related to metabolism and related to the anaerobic growth. Now, you may remember when I mentioned the growth rates early on that we hypothesized that there may be something going on in the common system, not necessarily the metabolism systems or the oxygen. Well, what we found in both of these GWAS and GWAS analyses is that transcription happened to be the that was most represented by itself at 13%, outside of function. For now, I'm sure there's some really interesting stuff, but that's another piece. Hopefully we're that. So we're seeing that in both cases, transcription is the most represented of the categories, categorized themes. So that may be, supporting our hypothesis that there is that whatever's going on is likely not in the oxygen responsive subsystems, but it's in some kind of common system, and transcription is part of it. So now with this data, trying to understand now why also we have these that are these genes that are present in only a part of our strains. We can now move forward to actually doing that RNA analysis that I mentioned, where we're now actually looking at the presence of these genes across anaerobic regions. And I forgot to mention that something that's really interesting about this, in both aerobic conditions and the anaerobic conditions, I did a quick and dirty analysis. And what we found was there really wasn't all that much difference in the growth rates between these phylogenies and these guys, the ones that don't have that don't have these. Again, what does that mean? I'm not really sure, but that's a really interesting question that I'm looking forward to trying to answer. So, are these guys making up for something that maybe is lacking somewhere else? Are these just not being expressed as much, and that's what these guys have to come in? What's I'm not sure, but that's and the last portion of this is, as I mentioned, how these genes have evolved in our strain. And basically what I mean by that is what evolutionary events have taken place that we see, MD1655 has this gene and W3110 has this gene. They're closely related, but everyone else doesn't have it. that's just a gross over, major over exaggeration. So what we're trying to do here is, as I mentioned, trying to search for, sort of trends in those evolutionary processes, whether we see a gene duplication where the gene gets duplicated within the strain, and then suddenly the gene A, there's two copies of it, and G655, that's only one copy, and W30%. Or horizontal gene transfer events where the bacteria are actually transferring their genes or portions of their DNA to each other. And horizontal gene transfer, you may be familiar, somewhat familiar with it. That's how we get a lot of antibiotic resistance, right? And basically the cause of a lot of antibiotic resistance is because we have one bacterium or a couple of bacterium in a, I don't know, a dish or something, at a hospital that is resistant to antibiotics, and then it will transfer a piece of its DNA over to a bacterium that's not resistant to antibiotics, and suddenly you have a population that is resistant. So we're trying to, again, search for trends in the evolutionary processes, whether it be duplication, gene transfers, in genes that are associated and not associated with the opposite. The way we do this is using the genome and using various statistical methods. We determine the history of the gene, of how the gene has evolved. And we do this in either a single gene or in gene families. So for example, I'm going to be talking about hydrogenase gene families, which is responsible for the reversible oxidation of hydrogen. Well, there's a couple of different genes that are responsible for that. So we could do that, or we could just go based on that. And we also take the history of the species, in this case, all our 158 taxa, or all our 158 strains. And what we do there is we take all of the genes that are shared. In this case, it was 1,162. So with 1,862 genes that will have only one copy in each one of our strains. And basically what we're able to do from that is take those, put those together, and using their process, able to create the evolutionary history for the species tree for our strains. And the way that we do this is we basically overlap the two. So now we have the evolutionary history of our gene, we have the evolutionary history of our species, we overlap those, or reconcile those. And that tells us basically, okay, well, this strain has this particular gene, but this strain doesn't. Then that tells us that here, at some point, there must have been a loss of that gene. Or this strain doesn't, but an ancestor had it, then, okay, it must have duplicated somewhere. And the reason why we're interested in this, or I'm interested today, is we know that there are trends in terms of evolutionary processes based on how those genes function. So whether they be oxygen responsive or really any other kind of gene function, we know that there are some trends. For example, for virulent related genes, we tend to see that they evolve through horizontal gene transfer, right? Antibiotic resistance, right? For metabolism related genes, we also see horizontal gene transfer and some duplication trends as well, depending on the gene, depending on function. So we're focusing on the hydrogenases again. We're not mentioning with the what the same, just the colors before. So as I mentioned, they catalyze a reversible reaction that's converting protons to dihydrogen. And the reason why we're interested in this is in previous studies in our lab, we know that there is two variants of these genes in particular in other strains, not the ones that I'm focusing on in response to auto. So basically what I mean by that is that when we grew these strains in aerobic conditions, anaerobic conditions with other strains, we saw that there was a difference. A lot of the enterobacteria encode multiple hydrogens. In particular, bipolar and salmonella includes those two. So one of the questions is one, how have these evolved, and two, why are there so many? What's the reason? What's the reason for this sort of overlap? And what we found is that for these hydrogenases, based on the reconciliation process that I described to you, we found that the hydrogenases have evolved primarily with the Basically, what that means is that nothing really fancy, at least for the hydrodynamics in these particular strings. What I mean by speciation is that when MG 1655 and W3110, for example, diverged in two new strings from their ancestor, they both got a copy of that gene from their ancestor. And that's basically what's going on for all of these strings. And the reason why this is interesting is this is different from the project that I did early on, where using 110 Enterobacteriaceae, where in this case, we're looking across the whole family of Enterobacteriaceae, where there's only one E. coli, only one Salmonella, and there's a lot of other strings that don't belong to those particular species. We saw that these same genes evolved through horizontal gene transfer. And that, in a way, sort of makes sense, because now we're looking at different taxonomic levels. If we're looking across beyond or above the species level, so not just E. coli strain, but E. coli salmonella, but any other bacteria. In a way, that makes sense because that's they're more evolutionary distant, so there's more than likely for those factors to take place, as opposed to when we're looking at the strains themselves in E. coli or salmonella, where now we're looking at some that only diverged evolutionarily speaking fairly recently. So there may not have been as much horizontal gene transfer for those that are much younger. Now, just to conclude, just to go over what we talked about here, most of the E. coli ortholog grade 4 genes are genomes by pair-relatedness. We're seeing a lot of variation. What's the reason behind it? I think that 80% of them genes that are responsive to oxygen are found in most of our strains, but what's making up for that other 16%? What genes are in? And why are we seeing some phylogroups have only a certain amount of genes? We identified some lineage-specific genes that appear to be associated with the growth rate. I don't know yet. That's a really cool question that I'm looking forward to answer. Some they have very similar growth rates, but for some reason have a lot of different differences. Why I'm not sure. And at least at our E. coli and salmonella folks, biological materials that speciation, as opposed to if we look back farther in time, now you see that these genomes have and the goal for my project in particular, or at least in respect to the final point, is that we do this across. So ideally, I would like to do this genome-wide, so not just on those that are responsible to oxygen, but metabolism, transcription routes, virulence routes. So looking at all at the evolutionary history of all of it, and trying to understand basically what's going on in the past 100 years. And just I'd like to thank my lab, including my lab and more support Kent lab, as I always like to support my lab test. And with that, I'll take you. And again, thank you so much all for your patience. Yeah.
But is everyone you're looking at, that go?
No. So we're looking at it primarily with its current, and the reason why we wouldn't go back that far is because the E. coli strains, or E. coli and salmonella, like I said, only go back 140 years. If we went back all the way back now, 2.4 billion years. And E. coli probably wasn't even around that, if I remember correctly. So yeah, so we look primarily at current times. Now that's not to say that E. coli T12 specifically hasn't been used for other studies looking around that time, or with oxygen levels around that time. Not to trash on any one science, but equal life, equal, because like I said, we're almost anything except our that. So yes, at least so to answer your question, I'm not looking back that far. I'm only looking primarily in present time. You know, just out in the open, oxygen, wherever that's going to hit. And you're good.
So during the season, the 54 weeks ago, January, I got my internet.
Oh, okay, awesome. Cool. Yeah, I have thought about that. That is something I probably should have thought of when I first started out here. But that is something that I'm interested in. I'm sure you're familiar with not Dr. Richard Lenski, who's over at Michigan State, I believe. He's been doing a directed evolution experiment for the past 30, 40 years, somewhere in every day is a new generation of cola. I think he only missed like a handful. So that experiment is now being continued. And we've done effective. So that is an experiment that's been going on. Now, in terms of directed evolution, it is something I thought of, particularly with, as I mentioned, increased oxygen levels. I'm really curious about, above atmospheric or above what we see here. And the reason behind that is I mentioned I'm interested in astrobiology, I'm interested in space biology. In that case, we're looking at how organisms respond to space or in microgravity. Well, we're looking at some of these systems that will eventually use to travel. They tend to have and obviously you don't want to pull a 01577 and suddenly you got a sick happen. So to answer your question, that is one of my interests to be able to do directed evolution to see how are they growing or how do they respond and are they able to adapt into I don't know. That is a goal. Again, hopefully for a postdoc. Yeah, I've actually never met him. I really wanted to meet him, but that is the next goal. And that's primarily once we do the gene expression analysis, we want to be able to knock these out what happens now. And also for, as you saw earlier, as I mentioned, we have a lot of these genes that are unknown functions. That's another way that we can try and understand what's going on between the growth rate of the gene expression with a particular set of people. I have not, but that is one way that we do it. Not directly in bacteria, which prefer originating from bacteria. So, but there are a lot of, but that is the way. Yeah. Yeah, so thankfully I don't do this. Otherwise I would be here for or in big what you call it, big class. So the way that we do this is we grow these in 96 well plates. So basically what it is a plate that's about that big. And there are 96 wells that are on that, and we use just 1 milliliter or 1.5 milliliters of of media bacteria. Then, and that's just the growth. Once we actually want to measure their growth, we're using only about 300 samples, so very small to rodents. And one of the concerns early on was, is that enough media? Is that enough for them to grow? And what we found is that so far, or I'm sorry, what we found in the literature is that it seems like that is a useful way of growing these. But our goal is, once we get closer and closer to finishing stuff, we're going to go back and do a couple of these in the way that we normally grow them, test tube, or in class, just to confirm. All right, so what are the concrete and there is growth going on in the picture. Yeah. Yeah. Did you hear that here? Okay, so you probably heard that from Sunday. Sunday Lemon. He's my mentor when he was mentor. So that concept is a concept that has to be is it a goal? Yes. Is it realistic? Probably not. So but the goal is basically to essentially have these cloud cities in the clouds of Venus. So the clouds of Venus are, at least to us humans, not habitable, but at least to certain forms of microorganisms are more habitable to them than the surface. Nothing can survive on the surface, at least life as we know. But in the clouds of Venus, what we're looking at is we're looking at a temperature of about 160 degrees Celsius, no, 150 degrees Fahrenheit. We're looking at temperatures, we're looking at pressures very similar to that here of Earth. We're looking at really acidic conditions into the negative. Before I got involved in the so that's place where some people similar to what we find here on Earth that we find in hot springs of Yellowstone or kind of some events bottom of the ocean. Now going back to the question of those floating cities, the reason why they were designed. The reason why they were proposed is for, basically having humans up in the clouds of Venus, studying not just that, is to collect samples and to basically do studies from the clouds because we can't get down to the surface. But again, it's just a proposal. If it were to happen, it would be sometime in 30 years. More than likely, if someone does it, it'll be a and it is a really good. Yeah, so during the pandemic, well, we're still 2 years ago, actually, yeah, about 2 years ago, I had my opportunity to be on and I had the opportunity to talk a little bit about Venus. And in fact, it was called the Planetary Showdown. Perseverance had just landed or had just taken off to Mars. And actually, no, it wasn't on the planet because the Bastone discovery that's not controversial. So Venus had just been announced. And basically, I had a showdown where we were talking about why Venus, Mars, the other person, geologist professor from, and we basically had to I'm very much Team Venus. That's not to say Mars isn't. That's usually the reaction I get. That's not to say that Mars isn't a great place to look for life. But I mean, we've been looking there for 40 years. And I'll see you. Yes, thankfully I'm a volunteer for that, so I can't get fired. Or actually, no, well, actually maybe I can, but let's think of that. Yeah, no problem. We need to have.
Do you have a class scheduled next week? I don't know. 25 years.